Hello, everyone. Thanks for coming to a SONiC workshop. My name is Zhenggen Xu. I come from LinkedIn. Today we are talking about the LinkedIn adoption of SONiC. So I'm going to share some experience we had and some practice we took, to adopt SONiC in our production network. So before we go all that, I want to quickly go through what LinkedIn, the data infrastructure. We have 5 data centers and 20 POPs globally. We have more than 200K servers, located in different locations. And we have a pretty fast growth of the data infrastructure, more than 30% growth every year. Now we have more than 600 million members globally. And with these numbers, because nowadays, for example, machine learning, all this, the technicals is happening in the application. Actually, we generate more and more traffic, right, inside the data center. And this basically has requirements, for the switches, to take care of that. But people may still ask, why we built the network OS, right? So this is actually started with the journey we had, with the networking disaggregation, right? We want to actually separate the hardware and the software. I mean, this is really the industry, driven also. But at some point we realized that's not enough, right? We really want to own the whole software, this whole OS stack to actually take advantage of ASIC capabilities, or to actually run some your own applications, or actually can debug things or pinpoint the issues much faster if you own the end-to-end, right? Of course, there's some other benefits, we have independence and we can control the risk and other things. And the other thing I didn't even mention here is the cost, right? This can save a lot of cost for the switches. But why we choose SONiC, right? It's not because we are Microsoft now. It's I mean, at the time when we pick, when we had that vision, to build our own OS, that Microsoft and the LinkedIn deal was not there. And also, when we actually picked the SONiC at the time, we actually did a very deep analysis, about the SONiC itself, right? Not just bluntly choose it. I think that this SONiC philosophy, fit our philosophy pretty well. For example, we really like a Linux-based system. We don't want to actually have a lot of changes in the kernel. We wanted so later if we want to upgrade to a new version of kernel, it's much easier. We don't maintain those patches or changes. And of course, a lot of things can be reused in Linux. I mean, we will give some examples later. Why Linux is so powerful. For debugging, for running the new applications and so on. And other things, many people already talked about this, right? That they container technology on SONiC, right? This is actually, we can pick the best components, from different places, like a BGP, for example, right? We end up using FRR in the beginning. We know that has better support, better features, and so on. And also the incremental upgrade. Alibaba also talked about that. You can upgrade Dockers, individual Dockers, right? The other thing, of course, is a platform agnostic. We want to build a platform actually is future-proof, right? So we don't have to change your software stack if you move to a new device or move to a different vendor, because I think different vendors they have different capabilities, or power efficiency, or new features, or telemetry, whatever, right? The last but not least is the community, right? When we look at the SONiC, it was the most active ones. It has a lot of contributors already at that time. But if you look at today, I mean, it's much bigger than when we actually had at that time also, right? Yeah, I mean, the keynotes you also see how many commits per month, how many contributors around this community. So what we have done, right, in SONiC, and we, as you can see, like maybe I go through like a little bit. You know, we had done the FR integration. I think we are the first one actually deploying FR in our deployment, right? And we upstreamed the changes to the GitHub, and I think now. I think it's the idea is to actually move the FR as a default protocol stack, right? And also some like IPv6 supports. We did like ACLs and link local, some gaps we filled, we upstreamed. And the other thing is the Bgp Convergence. I think we initially, when we evaluate SONiC, I think we had quite a bit of concern about the convergence time. I think one of the reasons is actually the architecture, right? It has the centralized DB in the middle. I think we're a little bit worried, right? Because everything goes through the database, right? So we did the quite deep benchmark for the SONiC at that time. Actually, we pinpointed some issues, you know, in different places, and we fixed them. One of them, for example, is there's some side improvements. I think we can. We have some slides to talk about that later. And the other thing we did was the FIP acceleration. I mean, this technology is not that new, but it wasn't there in the SONiC in the beginning, right? So this feature basically, you know, you may have a lot of ECMP links in the data center, right? But if the one of the link is going down, it's supposed, you know, all the traffic is supposed to move away from that link. But in reality, if we don't have this feature, basically, it will wait for the control plane to converge, right? To move all the routes from that link. If you have a lot of routes, actually, it will take seconds at least, you know, to get all the routes move away from that link. It means like you may have a few seconds like traffic loss during that time, right? So what we did is like instead of waiting the control plane to converge, we actually, you know, did some, you know, based on the link down events, we removed the ECMP next hops from the groups directly, right, from hardware. So that way, reduce the downtime from seconds to milliseconds. The other part is like warm reboot, you know, as Li Hua and the other guys also talked about. We spent a huge amount of time, you know, on that aspects. We had the great collaboration with Microsoft, Alibaba, and ourselves. You know, we had the trips, we had the like warm rooms, and make this warm reboot feature basically went to a November 11 branch, right? And we're still hardening it. I think, as you can see from the demo in the last presentations, everything worked good, right? So we have other white boxing onboarding and some operational improvements. The other things we did internally, it hasn't upstreamed yet, or it's kind of only fit our infrastructure. You know, there's something like, for example, how we manage the switches, right? We use pretty much leverage the same method we manage the servers, right? We use the same authentication or authorization method to manage the switches. And some other things like ZDP integration and Open19 onboarding, I think that one we can upstream once it's ready, everything. And the other thing we did was the incremental upgrade for Docker and the packages. This is something for sure we can consider upstream. We actually built like basically build some method to like how to tag the how to do the version control basically, right? We have different versions. You know, we need to make sure those versions are compatible, and we have ways to check that do all the sanity checks, and then we build the infrastructure actually to do these upgrades. The last is like integrations. Those things might not be applicable for the GitHub, for the community. So okay, so I'm going to share a few things about the experience we had and the practice we took for the SONiC. This is one I just talked about. In the beginning when we picked SONiC, actually there was some when we did the benchmark, we noticed that if like a number of routes keep increasing, we see the route convergence time actually increased dramatically. It's not like a linear, right? That's the dotted line you can see, like one-way or 32-way ECMP. And so eventually, I mean, this really come down to like we're using the Linux tools, we're using profiling tools to really pinpoint the problem. We use the profiling tools and we can get exactly which function, which line of code actually caused the problem, because we have source code, everything. And eventually we fix this problem, right? And the other thing I think is the testing part. I think the SONiC itself already has a pretty good test framework. It has a Google unit test for the libraries. It has like a virtual switch based like a PY test, do a bunch of stuff in the Dockers. And also we are building like a KVM based simulator, right? And it also has an Ansible test framework for the real DOT. But I think we noticed that this, like, for that Ansible framework, actually the visibility is a little bit lacking. So we end up building our own the framework, on top of it, or some of them is in parallel. Is the robot framework, right? Basically, as you can see from this screen, it's very easy to see like what test case you're running and where it's failing. And if it's failing, actually, you know exactly which line of test code is failing, and you know the output from the command, and whether why it's not the same as what they expected, right? So that's something we did. I think this save us a lot of time to when we add new test cases, and if we have a new image releasing, we want to pinpoint why it's failing, right? So the other thing I think Alibaba also mentioned is like how to do upgrade, right? So we think for like LinkedIn, for example, we're not a switch company. We don't have like a huge team supporting us, to all the QA stuff, to do all the testing. So we think the CI/CD pipeline is the way to go. That means you need like a fully automated pipeline. Once you get code, for example, from GitHub, sync to our internal repo, we build it, we run the regression, like from the development test framework. We just showed like the robot framework. Of course, internally, like the unit test framework as well. Then we also have a system level framework. We basically build a lab, real lab, right? Has T0, T1, T2, the switch is connected, so running some real traffic. And then we, once everything is good, then we put the image to the file server, and it gets synced to the HTTP server, and using the HTTP server, basically you run any cast, so it's available to all the switches with the same host name, right? So after that, it's more like we hand it over to the NetOps guys. They will pick up these images or the whole image or Docker images or the packages. They will do, for example, the first time they may use a ZDP to load the only image, but in later maybe they will do the upgrade for the Debian package or for the Docker images, right? So the funny thing, I mean, a few days ago, actually 2 days ago, we did the hackathon, right? We actually literally, like in one day, we actually integrate the Kubernetes to SONiC. We formed a team of 4, from different companies. And what I'm trying to say here is, I think because of the openness of SONiC, right, we actually can use even like some model management tools like a Kubernetes to manage all the Dockers, right, in the future. So in terms of monitoring, I think Alibaba also mentioned that there's some gRPC servers running on SONiC. So we actually, based on that infrastructure, we built the whole pipeline. We collect the data from the gRPC, and Then we actually run Kafka and send to the time series database, and then it can generate the alerts, and also we can process data. For example, one example is we can detect, for example, link flaps, right? The data processing pipeline actually can take actions to shut down those BGP peers. So this is something actually I did last year, some demo snapshot. This just show you like how flexible that infrastructure is, right? Basically, you can detect the link flaps, for example, in a very short period of time, like seconds, right? And also like something like internal information, like for example, number for next hops per route. You can pinpoint to exactly which routes, how many next hops you can detect. And the other thing I wanted to mention here is like for example, with this time series database internally we built, I think it is we can like define those rules, right? Really to generate alerts. So the point is here is I think we want to make these things actually a self-service. So we give this freedom for the NetOps guys. Actually, they can create rules. They can do, because they have more operational experience. What need to do with different events. So can actually things that can be a self-service instead of hard-coded anywhere, right? So just a few takeaways, right? We leverage like a powerful tools on Linux for debugging. As you can see, the previous like route installation convergence time issue, we use like perf tools. We can actually precisely locate the problem, pinpoint the problem, and we also like in the production network, we end up like seeing some problems with the Python program as well. So because then we actually use the py flame, for example, to debug those things. We can know exactly which line of the code in the Python actually causing the problem. And the other things we did is the test framework, just mentioned, is the framework, test framework visibility. And we think the CI/CD pipeline for deployment is the way to go. I don't think we need like a traditional QA team for that. And we build all the incremental upgrades in production. For monitoring, I think we do want to leverage like all the modern infrastructure or tools, right, to do that. Luckily, in LinkedIn, we have those, all those infrastructure. They're use that infrastructure for managing the servers and the applications. So we just leverage those, like Kafka, for example. We also have like internal time series database. Yeah, the other point is I think it's the self-service. We really want to, give the opportunity for the NetOps guys. Actually, they can define what they do with the actions they see, not really hard-code anything. And one thing I want to mention here also is we actually open up this switch environment for like net engineers and operation guys to actually step in. They write code on SONiC, right? They know like what CLI is good, for, based on the experience from different vendors. So they can improve like SONiC CLIs. They add, for example, like link flap counters or different things there, right? So the best practice I would say is collaboration, right? Collaboration and collaboration. I think all these features without the community is so hard to be done, right? Especially like for LinkedIn, any company that doesn't have a huge team for the switch development, right? Yeah. So with that, I'm going to like look in for the features in progress. This for sure we need a collaboration from the community. So one of the things I think many people talk about is the config management system, right? We actually had a draft design internally. We also talked with a few guys in the community. Today, I mean, the SONiC has some configuration database, right? But I think the validation logic, all these things is not is not perfect yet, right? We think we need structured data. We need to like define really the schema. So this is not like a one step for all kind of solution. We want actually to not disrupt the existing SONiC too much. So what we think is we want to have describe this config DB in a YARN-based schema. We have done some actually prototyping, for example, like VLAN port and VLAN tables. We can describe the schema, the current schema in the config DB, exactly the schema into YARN. And we use those libraries, libyarn and other things to do the validation and dependency checks, syntax checks, and those kind of things, right? This solution, the good thing about this solution is it's plug and play, and it doesn't really need the backend translation. We don't touch like the core part of the SONiC, so the config DB is still remain the same. In terms of like northbound interface, we think the GMI is probably the way to go. We already have as you can see from previous presentation, we already have like a GMI servers, right, running on the switch. I think we can just reuse that interface for the configuration as well. So the other features we're doing is the dynamic port breakout. So this feature is, you may think it is like how hard it is, right? It's just to break out the port to a different speed. But it turns out actually it's disruptive, from top to bottom. You need to change configurations. You need to consider different platforms. You need to change the orchestration layers. You need to change libsci, and all the way down to the ASIC side implementation, right? There's a lot of changes. So we had some internal discussion, had some design. I think we're going to like share with the community soon. So to to get feedback from you guys and get some help from you guys also, right? Because we need to, as I mentioned, side implementation has to be also done there. Yeah, I think that's for the again, I think we want a collaboration from the community, and I think this is some links, for the SONiC. You probably already seen there. Yeah, that's pretty much from me. Yeah. Thank you.
Questions? Okay.
Hi, great work. This is very cool. I've got one question about the route performance.
Yeah.
After like profiling, did you guys upstream the fixes?
Yeah, the fix is there, yes.
That's great. Thank you very much.
Yeah.
Okay.
Hello. Yeah, I want to know whether the test framework is available publicly on the repo, the one that you showed.
Yes. What is the question?
The test tool.
Yes.
Yeah, is it available on the GitHub?
No. So we are planning to actually upstream that, but I think we're talking with Microsoft and the community. I think we need some agreements, how to move forward. Okay. Today we have an Ansible framework, right? This framework is the test case is pretty much similar to what we have in the Ansible. It's just give you more visibility and more debuggability, So we are thinking, how to actually upstream this. So one of the ideas is probably like we can run this framework on top of what Ansible framework is doing. So we actually can get the upstream fixes. At the same time, we can add more and more, and we also have the benefit of the visibility, those kind of things. Yeah.
Okay, thank you.
But it's not upstream yet.
Okay, thank you.